So now that we've talked about the ImageTaskGang application in general, we've given an overview of its structure and its dynamics, let's talk more about its pattern-oriented software architecture. And once again, I'm a big fan of trying to describe and document complex software, especially complex concurrent and networked software, through the use of design patterns, through the use of UML diagrams, through the use of object interaction diagrams, and so on and so forth. Here, we're going to look at the use of patterns from the Gang of Four book, as well as patterns from the Pattern-Oriented Software Architecture series. So let's start off by taking a look at this. These patterns that we're applying are not just done to apply patterns for pattern's sake, but instead they're really intended to enhance the application and the framework's reusability, flexibility, portability, and performance. So it's really all the different things you'd want to do if you want to make a system that's easier to understand, easier to maintain, easier to port, easier to scale and optimize, and so on. So let's start off by talking about the first of the patterns that we're going to cover. This is really the most central one from a concurrency point of view. And this is the Proactor pattern, which again appeared in volume 2 of the Pattern-Oriented Software Architecture book, which was published over 20 years ago. It's hard to imagine that was such a long time ago. But what this pattern provides is it allows concurrent applications to efficiently initiate service requests and process the responses to those service requests asynchronously using typically a pool of threads. It doesn't have to be a pool of threads, but most typically it's a pool of threads. And if you take a look here, you can see that we've got this Proactor symbol, which basically says that's the pattern, and then the ImageTaskGang plays the role of the proactive initiator and the completion handler, and the executor completion service plays the role of the asynchronous operation processor. So if you read the pattern, which I highly recommend you do, you can take a look at this Wikipedia link for an overview, or you can read the chapter in my book, the POSA 2 book. Then you'll understand more about what these different elements do. And we'll talk more about it when we look at the code. Another pattern that's used here is the pooling pattern, which is used to have a pool of threads. In this case, we manage multiple worker threads and optimize their acquisition and release. Maybe a better word would be amortize than optimize, but it is also optimizing. And it's amortizing it by not having to create a new thread each time. Now, keep in mind, this is very important when you're using the traditional Java threads, which are now called platform threads, because you don't want to create and destroy them frequently. If you start to use virtual threads, it's less important to pool. In fact, you should not pool the virtual threads in modern Java, very modern Java, as I call it, Java 19 and beyond. But for here, we're using the traditional types of threads. And you can take a look here for more information about the pooling pattern. It's also in the POSA 3 book, and it's also covered in the POSA 4 book. The longest descriptions in the POSA 3 book, and you can also read a preprint at the link at the bottom of this slide. Now, there's another pattern called the future pattern, which is used to block clients when they try to read the state of an object. Basically, it's a proxy that will allow the computation to continue until the client, which in this case is the ImageTaskGang, absolutely positively needs to get the results. So here the executor completion service keeps track of these futures, and the ImageTaskGang gets a future back, but really more importantly, it's able to get the futures that because they're stored in something called the completion queue by the executor completion service. And we'll look at that in more detail when we walk through the code. You can take a look here at this link for more information about futures, which are also known as promises in some languages as well. The next pattern is a good old Gang of Four pattern called Decorator. And Decorator allows behaviors to be added to an individual object transparently. In other words, it won't affect the existing behavior of other objects from the same class, or even that particular object's superclasses. Instead, it decorates it by adding new processing behaviors. And we're going to talk about this pattern in more detail, but in a nutshell, what we're doing here is we're using the Decorator pattern in order to be able to decorate the filter superclass with different kinds of decorators, like a null filter and a grayscale filter and so on, as well as something that can output the results of those filters to a local file on the file system of whatever device we're running the program on. So this isn't strictly related to concurrency, but it's an interesting example of using one of the more sophisticated Gang of 4 patterns. And you can see this link for more on that pattern. And I, of course, strongly recommend you read the Gang of 4 book. That's really the place to find the information about this. We also use the template method pattern, which defines the skeleton of an algorithm and a method, and then defers certain steps to subclass methods. And this pattern is used in various places. One place it's used is in the context of this filter hierarchy, where filter is an abstract class that has a template method called apply filter, and then that's overridden and implemented by subclasses like the null filter and the grayscale filter and so on and so forth. So you'll get a chance to see how this all works when we look at the code in more detail. And you can see this link or the Gang of 4 book for more information about the template method pattern. I strongly recommend you understand things like template method and the next one we're about to talk about, which is going to be factory method. But before we do that, just noting that template method is applied in multiple places in this design. It's applied in the filter hierarchy. It's also applied in the TaskGang hierarchy, because we have certain methods that are going to be template methods that'll call back to methods that are defined in the subclass. So for example, there's a method here called run, and when run is called, it's going to call a bunch of other things that are overridden by the subclass. So make task is one example of a template method. Run is another one. So there's a whole bunch of different ones we're going to see. And then finally, we have the factory method pattern, which I mentioned before, and that defines an interface for creating an object, but then leaves it to subclasses or to implementations to decide which specific implementation to instantiate. Very, very common pattern, very powerful pattern, used in several places here throughout this example to make stuff. Things like making the task is a good example of a factory method. So again, read the Gang of 4 book and/or look at this link for more information about the factory method pattern. So that's the end of the overview of some of the key patterns we're going to be using in the ImageTaskGang application. As we look through the code, I have actually commented the code to indicate what role is being played by the different elements in our class hierarchy and our class design by referencing what role they play in the pattern or patterns that they are applying. So that helps you kind of tie all the things together.